This video covers section 11.3, Logarithmic Functions, Objective 7, Solve Logarithmic Equations. A logarithmic equation is an equation that contains logarithms. We solve them by converting from logarithmic form to exponential form. For example, the solution to log base 2 of x equals 5 is found by using the definition of a log, and that is 5 is the exponent on 2 to get x, giving us x equals 32. Now, anytime you solve equations with functions that have domains that are not all real numbers, we need to be careful. Logarithmic functions or logarithmic equations can give extraneous solutions. This happens because in the expression log base a of m, both a and m must be positive. So to solve any of these logarithmic equations, I'm going to think of them as 4 is the exponent on my base of 3 to equal 5x plus 1. So I say 4 is the exponent on my base of 3 to get 5x plus 1. That's 81. And so you subtract 1 from both sides. To equal 5x. Dividing by 5 gives us x is equal to 16. Now, if I plug that back in and check it, it's going to say log base 3 of 5 times x, which is 80, plus 1 is log base 3 of 81, which is 4, and so it works out. When checking, we're looking at things like, are we taking the log of a negative number, or is the base proposed to be negative? We can't have negative numbers. Letter B, 2 is the exponent on the base of x to equal 16. We're converting to exponential form first. Now, we can take the square root of both sides on this one and get x is equal to plus or minus 4. If x equals 4, that says the log base 4 of 16 is 2. That's good. But if you say x is negative 4, that's the log base negative 4 of 16, which is not defined. Here's this extraneous solution. So the only solution to this is x equals 4. And here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out. And come back when you're ready to see the solution to these. Now that you've had a chance to work these out, I'll work these out with you. Practice 7a, solve log base 4 of 6x plus 4 equals 3. Logarithmic equations have the equivalent exponential form. 3 is the exponent. Logs always equal exponents on the base of 4 to get 6x plus 4. 6x plus 4 equals the base of 4 cubed. 6x plus 4 equals 64. Solve that simple linear equation. Subtract 4 from both sides and get 60. Dividing by 6 gives us x is equal to 10. Letter B, convert to exponential form. 2 is the exponent on x to get 64. We take the square root of both sides. When we take square roots of both sides, we use plus or minus. And so that says x is plus or minus 8. But only x equals 8 checks out. X equal to negative 8, log base negative 8 of 64 is not defined. So we get the solution x is equal to 8. Example 7, solve these common and natural log problems. So it's a little bit weird at first to see the base omitted, but whenever there's a missing base on the log, you write 10. If there's a missing base on the natural log, you write base e. So this just says that negative 2 is the exponent on 10 to equal x plus 1. This says that x plus 1 is 1 over 10 squared, or 100th, or x is equal to 1 over 100th minus 1. This is 1 over 100 minus 100 over 100, or x is equal to 1 minus 100 is negative 99 over 100. Letter B, 4 is the exponent on the base of e to get x, or x equals e to the 4th. Typically, we just leave it like that as e to the 4th, or we could estimate it if we're asked to. To estimate e to the 4th, we would need our scientific calculator. We find the e to the x button, put in a 4, and we see it's about 54.598. It makes sense that it's so big because e is close to 3. And 3 to the 4th is 81, so about 54.598. So again, we only estimate if we're asked to, especially if it's an application problem. But x equals e to the 4th is the exact answer, as I call it. And the approximation for the solution is going to be 54.598. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out. And come back when you're ready to see the solution to these. Now that you've had a chance to work these out, I'll work these out with you. Log without a base is considered to be a common log, or base 10. 4 is the exponent on my base 10 to equal x minus 20. 10 to the 4th is 10,000. Adding 20 to both sides gives us 10,020. Natural log of x. There's a base of e sitting there. Negative 2 is the power on e to equal x, where x is equal to 1 over e squared. That would be the exact answer if I wanted to estimate this. I would have to use e to the negative 2. And rounding that to 3 decimal places, 0.135. And this concludes the video for section 11.3, logarithmic functions. Objective 7, solve logarithmic equations.